Back again to our video tutorial on our YouTube channel Wi-Fi Tech Lab. Of course, today, as we mentioned on the last video, that we will be dealing with a spanning tree with also port channels, Etherchannels. So basically what we have here on screen, as you can see, we have 4 layer 2 switches. We have switch 1, switch 2, switch 3, switch 4. Okay, so we have switch 0, switch 1, switch 3, and switch 4. Right, if we pay attention to the switch 0, which is this one, as you can see, we already placed some naming to specify that this device also already elected as a root bridge. Right, a root bridge is elected by other switches based on the MAC addresses. Right, the first thing that determines which switch or which device is gonna be a root bridge, it's gonna be a bridge priority. Okay, so if the bridge priority is configured, it's usually ranging from port 0 up to 65,535. So if the devices, or if there are two devices which are sharing the same bridge priority ID, and then there will be a draw, which means now the election will be determined based on the lowest MAC addresses. So whichever switch that have a lowest MAC address, it will win. Okay, so it will become the root bridge. Now if you pay attention, all the interface ports surrounding the root bridge, they are called the desirable ports. Okay, and then whichever opposite ports of the root bridge, they are called the designated, they are called root ports. All right, they are called root ports. So this interface on gigabit 0/1 and 0/2 on a switch 3, it's called the root port. It's on the forwarding state. And also if you check this one on switch 1, fast Ethernet 0/1, ranging from fast Ethernet 0/1 up to fast Ethernet 0/3. And also if you look on this side as well, you will notice that we have a loop on a switch 2. Okay, so which means this is in a block state, because remember the spanning tree protocol is used, or we use it, or by default it's enabled on every switch, so it detects and look for the loops. Okay, using something called BPDUs. BPDU stands for Bridged Protocol Data Unit. Right, okay, now if you pay attention, remember we have said that these interfaces are redundant. The whole idea of spanning tree is to block such links. However, here we have used Etherchannels, right, so that if one interface break or two of these interface breaks, the link will be still up. It will be able to forward or transmit the packet from a certain host towards a certain host. Okay, let's make an example. So what we'll do is we will come to the switch that we call a root bridge, and we're gonna run some command on it. Remember the first command that we have to use in here, it's called enable, and then we're willing to show the configurations on this switch, so we'll just say show running config. I'll just keep it short for now. We are using a prevalence. Okay, let's see. So this is the host name, switch 1. The spanning tree mode is prevalence spanning tree, and then if you come here, you will also see that the priority set on this VLAN 1 is 24571. So we expect that when we come to this switch and the other switches, we will expect to see highest priority more than this one. Hence, if we have other switches that have similar, or they have equal number of these priority sets on them, then we will look for the MAC addresses on the interface, okay, on the switch, right? So let me just go down a bit. So if you look here, we are looking for the configurations that are done on this switch. So there is interface port channel 1, and then we on the port channel 1 we have said that the switch port trunk allowed is VLAN 1. Of course, if you have configured the VLAN, this is a VLAN 1, you remember it's a default VLAN, which means it's a native VLAN, okay? So, and if you check in here, switch port mode trunk, all right, and then if you go down a bit, this is another a group. So we're just saying interface port channel group 3, switch port trunk allowed VLAN 1 also, okay. Let's further go down to see the protocol. So we still have to talk about PAGP, and also we will talk about the LACP, and then we will also talk about that manual mode, okay. I'm just showing us the configuration that we have saved on the NVRAM of this device, all right. So this is disable, this is disable, this is disable, okay. Now let's go down a bit to see. So we have this as on, this is also in an on mode, okay. Now what we're looking for, actually we wanted to see exactly the number of the priority that we have. So we have seen that the priority of the root bridge is 24576, right? So let's come to another device adjacent to it. Let's look for this one, switch 3, and see what's gonna happen there. So if I click on a command line interface, I'll be able to enable the switch by tapping the command full enable, and then I'll just say show run, okay. So let's see, if you pay attention on the priority, it's higher than the one that we have been looking for in this switch, right? So if I scroll a bit up, you will see this is 24, and then this is 28, okay. So I'll do the same thing on this one to see. Enable config terminal do show run, all right. Okay, let me just scroll up a bit. Okay, so basically if I pay attention on this switch itself, I don't see the root bridge ID or the priority configured on it. So let's look for another one, or we'll check and look for the MAC address of this device, all right. Let's come to this one that is on the block state. Enable show run, okay. So even this two, it's not configured as the priority was not configured manually on this device, all right. So the competition was elected in all of the devices, however this was elected as a root bridge, all right. And this is our root port, as we have mentioned it, that the ports that are opposite the desirable ports, or that are opposite the root bridge, they are called the root ports, right? Now what we are gonna go through is demonstrating how exactly if we're willing to send the packet towards the specific destination, we're gonna see the packet moving and choosing the path and ignoring the path that is blocked. Obviously, if you want to send something toward this device from PC1, the path that will have to work is the path where actually there is no interface that is blocked. Okay, so we expect the packet from or the frame to start from PC1, and it's gonna go to switch 1. From switch 1 it's gonna go up to from switch 1 it's gonna go up to switch 0. From switch 0 it's gonna go to switch 3 up along to PC3. all right, now let's do that now by clicking a simulation. But before we come to a simulation, let me just confirm the IP addresses configured on each devices. We expect these IP addresses to be on the same subnet so that we won't have any we won't have any problem, sorry, so we won't have any problem when we're sending our packet. all right, so let's look for this one. As you can see, this is a class C IP address. It have a subnet mask of 255.255.255.0, and then we have a host IP address which is 192.168.1.12, and the default gateway is 1.1.1. remember, the default gateway, we only use it when we're willing to break out from the local area network, right? As long as we are sending from inside, so we are fine with only IP addresses. And then if I come here, okay, let me just delete this a bit. So if I come here on PC2 on the network interface card, remember this is a simulation tool that we use from Cisco. It's called the Cisco Packet Tracer. You can always go to the site from Cisco and sign in, create an account, sign in, and go to the download field, and then you can get this simulation tool. all right, so if I come to IP configuration, remember the other one, PC3, have .12. this one is also in the same subnet mask. It belongs to class C. This is a class C IP address, 192.168.1.13. this is a host IP address, and then we have a default gateway, so we don't need a DNS in the server. all right, so if I come to PC1 also, if you pay attention, we have .11, and then I'll just quickly go to PC0 and look for the same thing. If I go to PC0, we have .1, .10. all right, so we have confirmed now that these devices they are belonging to the same subnet. all right, another thing that I want to verify, so I'll make sure that there won't be any a problem that we come across, is to make sure that the VLAN is allowed here, the VLAN is allowed here, and the VLAN is allowed here, and also the VLAN is allowed here. I want to look for the VLAN configured on issue. I know that we haven't spoke about, we haven't touched upon the VLANs configuration. However, we just gonna talk about that soon. So what I'll do is I'll just say do show VLAN. Okay, I want to see the VLAN configured on each of these devices. Luckily enough, we have no VLAN configured. We only have a default VLAN of ID1, and all the interfaces, they still belong to the same VLAN, which is a default VLAN. all right, I'll do the same thing here. I'll run the command. I know for sure that this is the VLAN that is active in here, but I'll just make sure that we don't have any problem. Config terminal, and then I'll just type the command do show VLAN. all right, so this command is still giving me the same display as we seen on the last command. So as you can see, all of these interfaces belonging to default VLAN ID1. all right, okay, so what about the other missing interfaces? As you can see, faster than 01, faster than 05, up to 24. Where is 3 to 1? Remember that we have something called Etherchannels. So all of those interfaces that belong to one group now. All right, we will come to that. We will look for them specifically. Now let's check this one, switch 3, and see which VLAN is configured in here. The reason why I'm looking for the VLAN IDs or the VLAN names, it's because if we had maybe VLAN 10, we would use the command switch port trunk allowed VLAN 10, or you can list the number of VLAN, or you can just say all, so that all of the VLANs would be included to that switch. Right, so let's do this. Let's say do show VLAN. Okay, as you can see, also here we still have the same thing. And on this one, if you pay attention, I'll just spread this. Okay, as you can see here, on this switch we have the interface fast Ethernet 0 to up to 24. It's only F1 which we don't see, right? Fast Ethernet 01 that we don't see. All right, the reason why it's because it is part of the static mode that we set, this one here. All right, it's also part of Etherchannels. That is the reason why this interface is missing or on display or on the output of this command. All right, now let's come to the last switch, which is switch 2. Let's verify if we have only the native or the default VLAN by typing the command config terminal, and then we will write the command or type the command do show VLAN. All right, because I'm willing to see what VLANs are configured on that switch. All right, globally on that switch. Right, so this is what I see. Also, I'm seeing the same thing that I saw on the other one. If you pay attention, we have fast Ethernet 0, 2, 3, but I don't see. Okay, there is 4, 5, 6, 7, 8, 9, 10, 11 up to 24. As you can see, 1, I don't see 1, so 1 belongs to it belongs to the static mode that we sent here, which is part of the port channels. All right, now what we do is we have verified that on all of the switches the command to allow to the VLANs or the native VLAN is configured on all of the switches, so we won't have any problem when we're trying to send the packet from PC1 to PC3, or when we try to ping the we're trying to ping PC0 from PC2, and then we will observe PC2 sending the frame through the switch, and then the switch will not obviously use the loop here, because this is a loop and then this is a block state. Obviously it will use this LACP channel, which is called link aggregation channel. So, and then it will also go through the PHP, all right, which is Cisco proprietary Etherchannel, that protocol that we use, and then it will go up to PC0. Right, now let's do it. Now let's observe. I'll just select simulation mode, and then I'll try to go here. There are two ways I can do this. I can actually cancel this. Okay, I can go to the command prompt itself and then try to ping. Remember, this was PC12. I can just say ping 192.168.1.12, right, and then I'll press enter. Right, so okay, let's wait for it. Okay, let me go to real time. Okay, obviously it's got okay, let me just do this. Obviously we have, okay, so it did send the ICMP echo, and then it got the reply. So what I'll do is I'll just replay this so that everyone will see. I'll just do this. I'll take this packet and then I'll place it here. Let me see if I can move this a bit. Or I can move this a bit, and then I'll just place it here, and then let's observe. So PC1 leave the packet leave PC1, and then the switch, it's direct the packet exactly where it's supposed to go, because now it knows that if it goes to this way, it won't be able to reach there because it's gonna be blocked. Because now if you look, port FA05 on switch 2, there is a block state, right? There is a block state, which means it wouldn't work now because that port is blocked by the spinning tree. All right, and also there is a loop in here. It wouldn't go this way and then go up that way and go there, right? Now we have received the packet successfully, right? Now let's pause this and then we'll delete it. Let's see what was gonna happen if we were to send the packet from here. Let's send the packet from here to here. You will notice that the packet, it won't go to it won't go to the switch 3. The reason why is because this spinning tree is blocking this port in here. So obviously it will come down to this device in here, which is switch 1, in order to reach this PC2. all right, now let's play. As you can see, the frame or the packet leaves from PC0. It's got flooded to everyone. The reason why it's got flooded to everyone, it's because it is the first time we are sending the packet from that device, and the switch itself from a root bridge, it have no MAC address table or the entries or app caches for PC2. okay, so next time it send the packet, now what we will do, it will, because it have received the reply from PC2 with its MAC address, it have saved it to the MAC address table, and then it will be able to send exactly the frame towards PC2, or the packet towards PC2 next time, because it's not exactly where is it located. We already discussed this on a previous video, but it's very helpful to keep on touching and dealing with it more often. all right, okay, we will see exactly. So if you pay attention, this is what was going on. This is a layer 2, which is a port faster than 01, which is the network interface card of that device in here, of the PC0, and then it was going toward a certain MAC address sorry, of PC0 from PC0. So it was going toward a certain MAC address, which is PC2 or MAC address. It didn't know it at first, so the switch itself just flooded the packet to everyone, except from the packet that it received it from, which is PC0. And then the PC2 replied and said, okay, I have that I have that MAC address, and then the switch saved the MAC address to its MAC address table. So if I come here and say do show, okay, let me do this, do show MAC address, you will see these are all MAC addresses. But if I want to see the MAC address table, sorry about that, oh god, do show MAC address table this is what we see. Okay, this is what is dynamically learned. Right, so this is a VLAN 1, and then this is a port channel 1, this is fasten 04, and then also this is port channel 1, and then also this is port channel 3, and then we have all of this bunch of interfaces, which is 1, 2, 3, 4. Right, this is the MAC address table of switch 1. All right, now this is the ICMP echo reply. And okay, so the IP header of the source was this one, 192.168.13, and then the destination MAC address was 1.10, and then remember this is an app, so which means if the packet leaves from the source MAC address, it will come here with an IP header which specify the source IP address and also the destination IP address. Remember, we are pinging this. If we're pinging PC2, which means we know its IP addresses, its IP address, but we don't know the destination MAC address, right? So how we have to get the destination MAC address is by using the source MAC address of where the packet is leaving from, right? So yeah, what we're gonna do is we're just gonna pause this for now, and then we just gonna switch to exactly how to create these port channels and so on, right? So let's do that. So basically this is the lab. This is a simple lab that we're going to be using to demonstrate layer 3 Etherchannels and also layer 2 Etherchannels. Remember, we are saying layer 3 Etherchannels because there is an IP address involved, right? And then this is a layer 2 Etherchannels because it's based upon frames. All right, so basically we have Etherchannels. Etherchannels simple means that we have a bunch of physical cables that are bundled up together to create one visual link. All right, so what we're willing to achieve, this helps us as many multi-purposes. This helps us so that if maybe one cable fails, and then the other one will be able to operate normally as if there is no issue with one cable. Okay, and then if maybe the other one fails also, this will also be able to carry on operate as normal. All right, so we'll be able to send the frame or the packet from PC8 to PC9 even if this is on a shutdown state or it's broken somehow. All right, so there are 3 modes that we can use. We can use a static mode, and then which is and then we can also use LACP mode, and then we can also use PHP mode, right? So let's start by looking at switch 2. These are the configuration that are configured on switch 2, and then these are the okay. So I'll just change this to switch 1 so it won't be confusing us, because it looks like that we have 2 namings with common names. So this is gonna be switch 1. Let me do that now. Okay, so this is gonna be our switch 1, and then this is gonna be our switch 2. So what we have in here, we just said the interface range. We willing to select the interfaces on the switch. Remember, we have 2 interfaces. If I'm not gonna count faster than 0, ever since this is a standard cable, straight through cable, which is directly connected to the PC on the left hand side. I just want to use this. Let me just put a ring in here so that everyone will be able to see what I'm talking about. I just want to put a ring without no color. Okay, let me just do this. I'll just close this and then I'll try to reopen it again. I want to put something like this, a ring, which will demonstrate how the aggregations are are configured and how to point it. Okay, so basically what you see in here, we have two physical cables. This is a crossover cable or the Ethernet or RJ45 cable. So what you have in here, we have two cables which are physical cable. Yes, exactly, physical cable. They are bundled up together to make a visual cable. All right, it's a visual link, right? So what we're willing to do, we are just saying we want to combine these two interfaces as physical cable to one. So we're just gonna, on the switch, the command that we have to type is the interface range. This basically select the range of those interfaces that you want to use as part of that visual link, right? In this case, we have fastener 01 and fastener 02 on our left hand switch, on our left hand side, which is on a switch 1, right? And then we have to specify the channel group, which is channel group, and then we can follow with the ID. This could be any ID that you prefer. In this case, we just use group ID 1, and then we use the static mode on. Okay, and then bear in mind, if you're using this mode as on the other side or on the other link, also on the other device which is directly connected or which is point to point connected to the switch, we have to specify that the mode will be same as the other mode, right? So what we do is we have to say channel group 1 mode on, and then we exit, right? And then we have to now select the interfaces. So we have to say interface port channel 1. We want to allow the native VLAN. So in fact, let's go check, because I think there is no VLAN which is configured in here. So the reason why I'm saying native VLAN is because I'm suggesting that there is no VLAN configured here. However, even if there is specific VLAN ID that we found, we have this command here which says switch port trunk allowed VLAN, all of them, right? So let's do this. Let's type in the command config terminal, and then we can just say do show VLAN. Okay, so if you pay attention, we have VLAN 1. This is a default VLAN. Of course, this command will fit even if we have VLAN 10, 20, 30. Okay, so we just said now interface port channel 1, and then switch port trunk allowed VLAN is all of them, exit, and then we just said interface range fast 0, 1 up to 2. We just want to hook them up because by default the interfaces are down, so you have to specify the command that says no shutdown. All right, so and then the interface, they came up. Now on the right hand side, we had to do the same thing also, and then we had to say interface range and select these interfaces, which is fastener 01 and 2, and then we create the channel group, which is 1, and then we use the mode on. In this static mode that we have used in here, which are we using to link this visual or this physical cable into a link to the visual link. So we could have used LACP mode, and also we could have used a PHP mode, right? So in LACP mode active, this initiates something called the negotiation, right? Auto negotiation. And then so on the other end you must specify, so you're just changing only the state. So you change it from on and put active, and then you change from on and put passive on the other end. So this receive, this send. So this initiated, and then is this one waiting, which is it's receiving, so it's waiting. Okay, and then also on the PHP we have a desired mode, which means the other one on the right hand side, it have to be on auto. However, we're just gonna demonstrate it now while everyone is watching. I'm just trying to show and explain this further. so that we won't have any confusion when I'm doing this on hand. All right, so and then we have set interface port channel 1, and then switch port trunk allowed VLAN all, and then we exit, and then we set interface range fastness 01 up to 2. All right, now let's do that. Now let's do a test by pinging this and see what's gonna happen. So if we ping PC8, we expect to see that the packet will leave from PC8 to PC9 without any issues. Okay, let's send it out. As we can see, the PC reached PC9, and then PC9 will have to reply back to PC8. Okay. Okay, now we're gonna see the status will be saying successfully. Right now the status says successful. I'm just gonna pause this again. Remember that we have two modes that we have here that we still have to use, which is a link aggregation control protocol, and then also we have port aggregation protocol. Right, so this is a link aggregation control protocol, and then the other one is port aggregation protocol. Okay, now what we have to do is we have to try and disable faster than 01, okay, and see what's gonna happen after that. So what do? We're not gonna, remember, if I go to the port channels, if I do the command do show interface or IP interface brief, so okay, I will see the VLANs and the gigabits, and then I will also be able to see the port channel which is up, which is this is the port channel. I could manually close or shut down this interface, right, as a whole, but I don't want to do that. Okay, let me do that in fact, so that everyone will be able to see. Now remember, all I need to know is I need to know the ID of this group. So this is port channel 1. So what I'll do is I'll just come here and say port interface port channel 1. Right, so let's do this to verify. This is port channel 1. Let me see if I come here and then I say port channel port channel 1, and then the interface is selected. I'm on the global config mode, and then I'm also in interface mode, so I can just say no shutdown. You will be able to see that now after I press sorry, I must specify the command shutdown. Right, as you can see, the interface or the state just automatically shut it down only on the left hand side. The reason why is because I didn't shut it down on the right hand side, which is switch 2. I only shut it down on switch 1 on the left hand side. Alright, so the interface itself, so the visual link which we actually link the physical cable fastness 01 and also fastness 02 on our ports on the switch on the left hand side, which is switch 1. So the whole port channel is just down. Alright, so in order for us to send something to the other end, we will have to hook this port channel up by typing the command no shutdown. However, let's test again. Let's see if we try to ping another device which we pinged last time. Okay, we're gonna ping from this device, which is a host 192.168.1.2, and then we're gonna come to PC9 and go to its network interface card to verify which IP address is obtained in there. Remember, we're not using a DHCP, we're using static IP address. So we're just gonna ping this IP address and see if it's gonna give us any reply. So right, let's do this now. We are sending an ICMP request. So 192.168.1.1 or .3, sorry. So I'm just gonna do this. I'll just play it so that everyone will be able to see if it's gonna be able to. Let's do this. Let's see what's gonna happen. In fact, let me just play it here. Let me put it to a real-time simulation, so you'll be able to see that we're getting a timeout, right? So I'll try to ping it again one more time so people will be able to see that I'm getting a simple timeout when I'm trying to ping to the PC, which is PC9. All right. As you can see, when the packet or when the frame leave from PC2 to the switch trying to reach to PC9, because now the interface is shut down, the packet is being dropped, all right, by the switch. All right, let's run it one more time. The continuous ping is not valid. Okay, let's do this. Let's try to go to the switch itself, and then we're just gonna hook. Remember, this is what we get, the debug messages, as you can see. So let's do this. Let's just come in here. So as you can see, this is a line protocol on interface port channel 1, and then it changed its state to down, right? So if I come here and run the same command, do show IP interface brief, do show IP interface brief, I'll be able to see that the first interface, which is a port channel on the list, is administratively down. Administratively down simply means that I am the one who just shut it down, right? So this is manually administratively down, and the protocol is also down, right? So how do I correct that? So I have to come up and say no shutdown, right? And then as you can see, the state just changed now from the down state to an up state. I'll just do the command again, do show IP interface brief. Okay, as you can see, the protocol is up, and then also the status is up. So we will be able to do a ping now. As you can see, it's getting ready, and then I'll be able to send a ping from PC 8 to PC9, right? So let's do that now. Let's verify if it's gonna work. So 192.168.1.3, as you can see, we're getting a time to live. Okay, and then we're getting the ICMP echo reply. As you can see, we have sent 4 packet, and then we have received 4 packet, and we didn't lose anything. There is 0% loss. All right, so let's come in here. Let's now verify by shutting down exactly the interface, one of these interfaces, which we call them physical cables. All right, so let's choose any of these between fastnet 01 and also fastnet 02. So let's look at fastnet 01. Remember, if I run the command fast ethernet, do show IP interface brief, I'll be able to see all of the ports associated or associated, yes, with that switch. All right, as you can see, we have 24 ports, and then we have extra gigabit ethernet ports, right? So what we're willing to shut down, we're willing to shut down this interface here, because we know that it might be here as physical, but it also included here on the port channel visually. All right, so we're just gonna select this interface and shut it down. To select an interface here on the Cisco switches and also in Aruba switches, you run the same command. So let's come here and say exit. We're just gonna say interface fastnet 01, and then we are inside the interface itself, so we can run any command related to the interfaces. So what we do now, we're willing to shut it down. Shut down the interface, shut down. right? The interface is down, but if you pay attention here, it doesn't say that the port channel is down. It's just saying only the fastnet 01 is down. Even though we know that the fastnet 01 is part of or associated with the port channel 1. So let's go check, let's go again and check and see if this is gonna work or not. Right, as you can see now, what we notice in here, if we shut down one interface which is directly connected to another interface, you will pay attention that on both ends the interface, they're just down. So we have if we come here on this switch and then we run the command do show IP interface brief, as you can see, this is the status of the fastnet 02, which is directly connected to fastnet 01 on the other end. So it's down. So if we come here and then type the command enable config terminal, and then we type the command do show IP interface brief, and then we'll be able to see that the fastnet 02, it should be down. This is the fastnet 02. Okay, so now let's see what's going to happen on the port channel. Remember that the whole idea of this is that even if the cable is cut on one interfaces, which is a physical cable, because of the bangle that we created visually, we will be able to still send the packet from the source to a destination without no issue until we resolve the damaged physical cable. Alright, so what we do now, we just come here and run the same ping. Alright, let's see, echo reply. If we're gonna receive it, let's send the echo request. As you can see, we are getting in time to live values. So what we do is this is what we got. So we got 4 packets when we send 4, so we didn't lose anything. So which means now we send the packet and then it, okay, maybe let's visualize this so that everyone will be able to see that the packet won't use this interface because it's down, so it's going to use the upper interface. Let's do that now. Let's send the packet again. Let me just reinitialize this. Let me just drag it from here, and then I'll move this a bit, so, and then I'll place it here. Now let's play, let's see what's gonna happen. So we're sending from PC8 and then we're sending towards PC9. Okay, so as you can see, it sent it with the upper interface as you saw, but let's wait for it to come back so you'll be able to see exactly this line where it's gonna touch. Okay, as you can see, the line, it's touching on an upper interface, which means it's using the interface which have the protocol that is enabled, which is up. All right, so as you can see, this is successfully we be able to reach PC9 even though the other interface is down. So now let's hook it up again one more time, right, before we actually use these link aggregation control protocol and also port aggregation protocol. Right, so let's say no shut. Okay, so we are expecting now that the interface is coming up. As you can see, now the port channel is working fine. Right, okay, so let's delete this and then let's go to a real simulation. Let's try to demonstrate this using another switch. We'll just keep this up in here. I'll take a new switch and then I'll place it here, and then I'll take another switch and place it here so that everyone will be able to see what's going on. I'll do the same thing and come to the cable selection. I will use this cable because remember what we said. We said we are using the straight through cable when we connecting the end host devices to the switch or from the switch to the router. So if you're using a crossover cable, you will use it only, not limited, but you will mostly use it to the devices of the same type. In this case, as you can see, we have a switch and then we have a switch. So by default, even if I auto select this by clicking here, it will choose the crossover cable for me, right? So as you can see, I've on the left hand switch, which is switch 0, I have fastnet 01 port, and then I also have fastnet 01 on switch 3. So what we do is we're just gonna select another cable, and then remember we have used fastnet 01, so these are all interface that we can still use. So I'll use fastnet 02, and then I'll also directly connect it to fast ethernet 02 on the right hand side. I'll keep on using about 3 of the physical cables, and then, or maybe I can even use 4 of them. Okay, I will use 4 of them. Right, so now this is what we trying to build. We are trying to build a visual link. Okay, visual link using physical cable, just in case if we have one that is bite or broken, we can still be able to use the rest as a support, right, until the other one is also fixed or replaced or repaired. All right, so let's do this now. We just need the devices on the other end, which is an host device, and then I'll use PC0 and PC1 in this case. What I'll do is I'll use standard through or straight through cable, and then I'll use fastnet 0. Ever since fastnet 01 is used up, I can use the last port, which is fastnet 02. Fastnet 024, and then I can also do the same thing on the other end. I'll just use the last port, which is fastnet 024. all right, I'll ignore the gigabits for now. Okay, so what we do is we are trying to demonstrate using the LACP mode, which is a link aggregation mode. Remember, we have specified and mentioned that in this mode, if we're using an active mode, an LACP mode, which is a link aggregation control protocol, one of the sides must be able to initiate auto negotiation. How are we going to do that? We have to use this mode as active, right? The command is still the same, however the mode is just going to change. And then on the right hand side or on the other switch, you must use the passive, right? So it's going to wait for initiative on the left hand side. So what we do is now we just gonna come here, and then we're just gonna okay, let's wait for that to come back. Let's start from the right hand side. Let's see what's gonna happen. Let's start from the right hand side. Let's do the command enable config terminal. Okay, let me just configure the host name so quickly. This is an alias to those who don't know what is a host name is. This is an alias. This is the name that I prefer, so I can just call it switch 1 or switch 2, but I will use the switch 2 for now. Okay, host name. Okay, I have to remove a here because my spelling is very incorrectly. So now, as you can see, change from switch to switch 2. Right, let's go back to the other switch and see if it's not ready as yet. Okay, I can okay, let's wait for it to come back. All right, so yeah, it's back now. Let's see. So, and then what we can do is we can just say enable config terminal. Right, so let me just do this a bit so that everyone will be able to see what's going on in the background. So again, I can configure the host name here by typing the command host name, and then I can call the switch 1. Right, so okay, so what we do now, we just willing to select the range of the interfaces that we are willing to associate with the particular group that we will create also. So what we do now, let's come here, and then we remember that we need to know the range of the interfaces that we used on the left hand side of the switch 0. So the only way to do that now is to run the command do show IP interface brief. Right, so as you can see, this is gonna list the bunch of ports or the interfaces associated with the switch, and then we're gonna see the ones that are down state means they are not used, and then this one is the up state, which means they are used currently. So as you can see, we have fastnet 01 2 3 4. Luckily these are consecutive, so what we can do is we can just specify the range by saying we want to start from range 01 up to 4. Right, so by typing the command interface range F01 up to 4. Right, so what we do now, because we have selected the range, so what we do, we create the channel group. In this case, I won't use the same group, I will use the different one, 3, 4, 5, any you can prefer. In this case, I'll just use 3, so I'll just come and say channel group 3, and then I will have to specify the mode, because now I want this part of the switch to be able to initiate the auto negotiation, right? So which means the other one will be a passive. So in this case, I'm using LACP, which is a link aggregation control protocol. So what we do now, I have to say active, right? Okay, let me do this. Okay, wait, there's something wrong, maybe I have to do it okay, let's do this. There is something wrong in here. Okay, I forgot to specify the mode, right? So there is something wrong that I was doing, so I just have to specify the mode that I'm willing to use. As you can see, now we have fastnet 01 up to 4. So it switched down the interface, it's restarted the interface, and then it's coming up, it's all coming up now as part of port channel, right? So the next thing that I want to do is I want to allow the VLAN, right? Just in case if there is a VLAN configured on the switches, they will be allowed to pass through. Remember, this is the switch, these are the switch. So what I'll do is I'll select the port channel, because now they are part of the port channel. Although we have physical cable which are fastnet 01 up to 4, they are now part of what we call port channel. So we have something called a port channel. Okay, so we're just gonna do that now. Interface port channel 3. Okay, this is interface port channel 3, and then we just gonna say switch port the trunk allowed. I can say VLAN 1, but in this case I'll just allow them all, VLAN all. Okay, now I can just say exit. So what is left to do is I have to say interface range from FA01 up to 4. I just want to say no shutdown, right? Do right. This is gonna be saving our configuration. All right, we can type do right or copy run. All right, so we have to do the same thing on the other switch. However, we just have to change the mode. So what we do is, okay, so let's do this. Let's try to send it now. Let's try to send and see if the packet will able to pass through. It won't, obviously, because now the other end is waiting. So okay, this initiate auto negotiation, but the other end is waiting. So before we can be able to send something, obviously the devices need to use the IP addresses on their network interface card. So I'll just manually select any. So I'll just use the same IP addresses. I'll say this is our default gateway, and then I can use any IP addresses, or I can point it to any DNS, but in this case it's not even necessary. I'll just remove it. Okay, and then I'll come to this PC, and then I'll do the same thing by typing the command 168.3, and then I'll just say 192.168.1. I'll leave everything as it is for now. Okay, remember what I want to do is I'm trying to send the packet, or I'll try to ping PC1 from PC0. I know its IP address, obviously it's 192.168.1.3. right, let's see what's gonna happen. so we can still be able to send it. Remember, we can be able to send it still. The reason why we are using the links, so there is only one interface, which is up, the first one. So let's find out which interface is that. Interface fast Ethernet 01, do show interface fast Ethernet 01. Let's see what's going on here. So as you can see, this is the fast Ethernet 01. It's directly connected to yes, of course, to that switch. All right, let's see. This is the okay, this is the IP address of that interface. Okay, this is what also gonna be able to help me, because if we run the command to show address or make address table, it's gonna show me the LAN IP, the LAN make address. Okay, so let's come here and also look for what is going on. Okay, now let's run the command do show interface do show MAC address table. Right, so these are what is dynamically learned. So basically the interface having learned any port channel that we have, which is port channel 3. In this case, it have been using what we call these interfaces to send. All right, so this is what is learned so far. So let's do that now. Because now remember, this is a native this is native, there is no VLAN created on the other end, so that's why we're getting a ping. Right, so let's do this now. Let's come on the other end and say interface FA01 up to 4 as well. So I forgot to specify something called range, because now we are trying to include multiple interfaces. So what I'm willing to do now, I have to say channel group. I have to put the group, I have to put these interfaces under the same group as the initiating auto negotiation mode of the active or of the LACP. All right, so I have to say 3 and then I'll say mode passive. Sorry, passive. Okay, as you can see, the interfaces went down and then it is coming up soon. As you can see, you'll be able to see now to change color from orange to be a green. Right, so let's wait for it a bit. Okay, as you can see, the interface just immediately went down and then it's coming up soon. So what we do is we have to allow the by typing the command interface port channel 3. Remember, if we go up in here, you'll be able to see that it changed the color again from orange to green. So now it's ready. So what we do now is we just selecting the group itself, or the channel, or the visual link. So what we do now, we have to type in the command switch port trunk allowed all switch port. There's something wrong in here. Switch port trunk VLAN allowed VLAN all. Okay, so to those who doesn't understand what trunk means it's simple, used to encapsulate the tag traffic. Okay, in Aruba switches, it usually simply means as an aggregation port, but in this case this is used for VLAN purposes. All right, so let's do this. Exit, and then we type in the command again, interface range. Even though I know that the interface are up, I can still say 0 up to 1 up to 4, no shutdown, to be sure. Okay, now if I send something across, you will be able to see that on the MAC address table the port channel is LAN. So let's run the command do show MAC address table. As we can see, this is what is used to send the traffic, all right, across. Okay, the port channel. So even if I break one of these cables by typing the command interface FA01 shutdown, okay, as you can see the status is down, I'll still be able to send a packet across successfully. So if I come back again and say to show, it's still showing the same thing. All right, so yeah, exactly, this is how we can actually configure the ALACP mode. Right now, let's create another interfaces. I will just create another interfaces. In this case, I'll just use these cables. I'll create interface 5. I'll create interface 6, and then I'll create 7, from which means from 5 up to 7. From 5 up to 7, as much as you won't see this physically, because yeah, it's just squashed up together. So as you saw me, I have a bunch number of links that I just added. So if I come here and say interface FA0, okay, let me just do this, do show IP interface brief. Let's see the interfaces that are from 5. As you can see, from 5 up to 7 we have newly added interfaces. These are the interfaces that I want to use to configure the port aggregation protocol. Right, so we're just gonna do the same thing, and then let's just do it. Let's start from the left hand side switch. So what I want to do is I want to select the range of those newly added interfaces by typing the command interface range FA05 up to 7, because these are the three interfaces, which is 5, 6, 7. Right, so it's ranging from 5, 6, 7. Right, so what I'm willing to do now, I'm just willing to create a channel group for them specifically, which is channel group. I'll just call it channel group 2, and then the mode that I'm willing to use is desirable, because this is gonna enable or initiate the auto negotiation, so it's gonna be desired. Okay, there is something that I'm actually typing wrong in here. Okay, channel group 2 mode, and then desirable. Sorry, the command is desirable. Whenever you're not sure about the command, or whenever the command that you thought was correct is giving you an errors, you can always type in the question mark, so that it's gonna give you the options. All right, so I'm willing to use this. Okay, I'm still wrong in here, so I'll have to put a desirable. As you can see, again, the interface is going down, so the bunch of those interfaces, they are just rebooting. Okay, so now that they have rebooted, what I have to continue to do is I will have to select the port channel that I've just created, which is a visual link, by typing the command interface port channel 2, because I use number 2. As you can see in here, I use number 2, so I'll have to type it again in here. I'll just say interface port channel 2. I want that to be able to encapsulate the tagged traffic and also untagged traffic, so I'll just type in the command switch port trunk allowed VLAN all. Right, so VLAN 1 and all other VLANs if we have configured any, but in this case we didn't configure any VLANs yet, so we're just gonna use VLAN all option. All right, and then we just need to exit, and then again we can just select these interfaces, FA05 up to 7, and then we can just say no shut down, and then we can do right this. All we need to do is to do the same thing on the other side, or on the other end of the switch. All right, let's come in here and type the command exit, and then we have to select the range. Remember, we have used the same interface port that are matching on both switches, so we still have to use the range from fastnet 05 up to 7, and then we just need to say you can just say no shut now, it's fine, and then we just need to create the channel group by typing the command channel channel group 2, and then we have to specify the mode. The mode is desirable. All right, the mode is desirable. As you can see, the interface is restarting. As you can see, the color change from green or from orange to yellow. As you can see also on the status reports in here, it says the interface fast and 05 it's down, it's up, and 6 is down, it's up, and 7 is down, and it's up. Remember, we're just dealing with 3 interfaces for now. So what I have to do now, all I have to do is I have to select the interface again, which is a port channel, and then I have to say interface port channel 2 in this case, because this is the ID that we have used. So we have to say switch port trunk allowed VLAN all, and then we just need to do right this, and then we can obviously exit if you want to, right? Okay, so now what I want to do is I want to shut down all the interfaces on the port channel 3, and also I want to shut down all of the interface and leave fastnet 07 only. So let's do that now. As you can see, the interface or the port channel 2 is changed the status to up. All right, so now what I want to do is, so that everyone will be able to see what's going on, let's first initiate a ping. Let's see what's going to happen. Remember, this is showing red because the fastnet 01 on that switch is down. The last time we shut it down. As you can see, this data is successfully, but let's go to the MAC address table. Let's see, do show MAC address table. As you can see now, we have a dynamically land port channel. All right, 2. Now let's shut down all of these interfaces. Let's see what's going to happen. Okay, interface range from fastnet 01 up to 4 shut down. Right, as you can see, the state has changed from up to down, up to down, up to down. Everything is down. All right, now as you can also see, the color have changed. So now what I want to do is also shut down the port channel itself, which is the interface port channel 3, right? Port channel 3, I can also say shut it down. Now even the port channel itself, which is a visual link, it's also down. The only link that we have is port channel 2, which is still up again. So if I send something across, I'll be able to get the ICMP echo reply. It's successfully okay, let me just delete this a bit so that everyone will be able to see. As you can see, I can still send something even if the fastnet 01 up to 4 is still down, and also the link that bangles them together, bangle all of those physical cables together, it's also down. The only port channel that I have left is port aggregation protocol, which I used, which is used on the fastnet 05 up to 7. So that's the one that now the physical devices, which is switch 0 and switch 2, is linked with to communicate PC0 up to PC1. All right, so I hope this video was so informative to you. Let's carry on with another video on an upcoming video that we just gonna drop. Okay.